Good. So the battery and the wireless keyboard run dry, and this is what we got. And after we put it on our pile of old batteries, we realized there are other sizes of batteries like this. Or like this. So all those batteries have something in common, and they all provide 1.5 volts of nominal voltage. At least that's what's written on it. And they are also all alkaline batteries. But when we shop for new batteries, we realize that there are also like tiny batteries and bigger, no, not bigger batteries, but box-like batteries. And they differ from the voltage of these 1.5 batteries of the AA and AAA batteries, because the small one, it's a lithium battery. Okay. Okay, this has 3 volts and this has 9 volts. There's another chemistry, so it can provide more oomph. But they're using the same chemistry. How comes that this one provides 9 volts and the other one just 1.5? And that's what we are going to find out. If you own like an RC toy or something like this, or something that doesn't run on one battery alone, you most likely have to put your batteries in alternating ways, like one with plus on top, one with plus on bottom, and the other one with plus on top, and then plus on bottom again. So why would you do this? Why don't you just put them all in the same direction? Because if you use them like this, like parallel, you could like wire them together here and wire them together on the top, bottom, and once what you will get is like a big, huge battery, just like this one. You will still get 1.5 volts, but you can draw it 5 times as long. Most of the toys and tools don't run on 1.5 volts, and therefore you have to increase the voltage. And you can do this by daisy chaining the batteries, just like this. They accumulate their oomph or their force or whatever. So we can see this. 1 volt, so this one is super flat. It's also 1 volt. And if we chain them together and then measure both of them, we should have like 2 volts. So it just adds up. 1 plus 1 is 2. So if we daisy chain the batteries of the same voltage, the voltage is added. Well, when we look at these batteries, we see that it is 9 volts. And 9 is also actually a multiple of 1.5, namely 6. So what I think is that these block batteries actually consists of 6 little batteries. And that's what we are going to find out by taking them apart. And for this I actually got 3 different brands. So maybe they differ. We see. As you might expect it, we are now handling with chemistry stuff we won't get into our bodies. Better safe than sorry. Number 1. The main difference is that, or one thing that gives it kind of away that something else is going on, is that you have both contacts up here. Here we go. And what do we see? You see it's shiny. Okay. So that's it without the thing. Okay, first surprise. Oh, that was this one. First surprise. The contacts actually come from the bottom. No, they don't come from the bottom, so they come from the top and from the bottom, you see. Then this is the negative pole and this is the positive. And this will just, yeah, there's the metal inside. See? And this strip will just pass it grabs it from down here and passes it up. So now we just see there are individual tiny batteries in there. And 1, 2, 3, 4, 5, 6. So yes, these will be like 6 tiny AA batteries that are just stacked over each other. Interesting. I put it here. So next we have this one, also kind of non-brand battery, and we see what they are doing. Second time is easier. Okay. I have the shielding on the bottom. This is that. And when we look at it, it's actually a little better glued. Oh, this is actually welded. So if you have a look at the other one, the contacts were just sitting on top of the battery and on the bottom. And this one is actually welded. Yep. Or it was welded. And the same down here. We spared no costs. This one is in its own tiny plastic casing. You see it up here reflecting down here, while this one is just wrapped in plastic. But I think they were both really cheap batteries. So now have a look at the quality battery. And it's silver again on the inside. And we see it's revealing something different. The metal is much stronger. And here we go, hopefully. Yes. Phew. And what do we have here? This doesn't look anything like this one. This actually is like a tiny battery pack. Let's compare it to AAA battery. They're actually like tiny AAA batteries and a little bit shorter. Okay, both contacts are welded on top of it. That's to be expected. Opa. And now we see the pattern I showed you before. They are also alternating, like top, bottom, top, bottom. Wait. See, so this is just a daisy chain of batteries. So theoretically, if you don't have any of these, you have a decent choice that you can take apart a 9-volt battery and pick up the individual batteries. Let's check this one. See, 1.3. So that's a dead. So that's just a dead normal battery. You see it's all wet and shiny, so we are actually in the middle of the battery, which is kind of a surprise. So this is blah. And then I think this will be the same deal. Yeah, and here we are in the guts of the battery, it's the same deal, but not as gooey. And luckily I have the gloves on my hands. Anyway, the inside's really funny because the expensive battery actually did create tiny batteries that they linked and welded together, and the cheapos are just stuffed batteries. So just stuffed chemicals over each other. Bah. Okay, I'm going to clean this up. Thanks a lot for watching.